So here we are at lesson 17C. In the next preview assignment and in the next class, you will learn to identify when graphs or other mathematical representations can mislead a reader who is not careful. In this worksheet, you will prepare for these objectives by looking at what you should ask yourself about visual displays and analyzing ways the data in visual displays can be distorted. So let's start with what are some questions that you can ask about visual displays. So looking at question 1, we should not even look at until you've hit pause and you've already looked at question 1, maybe questions 1 and 2 and 3, but definitely hit pause. Do most of these by yourself and then come back and work through the video on the questions. So starting with question 1, the list of questions below is on the first page of the resource in your quantitative reasoning material. In our case, it's our Math 1332 class, Understanding Visual Displays of Information. And it begins by saying, what questions should you ask yourself when you study a visual display of information? Make note of these, put them on sticky notes, put them somewhere to remind yourself, or just flat out memorize some cue words. And some of the clues might be, what is the title? What in the world is the question we're even trying to answer? How are the columns and the rows labeled? How are the vertical and the horizontal axes labeled? And then select a point and just ask yourself, what does it mean? And talk through what that individual point means. On question A, it asks for us to answer each of the 4 questions above about the following graph, if possible. If a question cannot be answered based on the data in the graph, then explain why, and answer space is given on the next few pages. And so the first question, and again, the answer space is given in your pages. So go there, listen here, and here's what's happening on part A. Question number 1. What is the title of the chart or the graph? Here is the title. The total amount of freedom in America. Question number 2. What is this supposed to be asking? Or what's the data supposed to answer? The data are supposed to indicate how much freedom America is enjoying over time. So here we notice time, and here we notice a value for freedom, we think. So move on to question 3. Question 3 says, right here, so here's our 1, 2, 3. How are the columns and rows labeled? And then, so how are the vertical axes labeled? Based on the context of what we're noticing, it appears that the horizontal axis represents years. There are no labels. There's nothing going on over here on the vertical axis. So we're not sure what it represents, but it does range from 0 to 100. So maybe it represents a percentage of total freedom. And then moving on to question 4. Select one number or data point and ask, what does this point mean? Well, this one is already highlighted. And so the 2011 data point, what is it? Well, I don't think we can be really clear on what it means. There are no units or labels for the vertical axis, so we're not sure what it means. We can kind of see what they're pushing us to. So let's look at part B. This was all under part A. Part B asks, so in what way is this graph misleading? It could be that you might say that there are no units or labels on the vertical axis, and this graph cannot be read clearly or critically, and so it's really meaningless. The author could mean to suggest that whoever was president of the United States in 2009, right around here, and 2010, which was Barack Obama, dramatically improved freedom in America. Write down a couple of thoughts and opinions, and let's move on and look for some more ways that we need to be analyzing data and information that are presented to us. Question number 2 starts by showing us a chart, which is on the second page of your resource, which is in your Quantitative Reasoning or Math 1332 course inside of my math lab, or if you bought the in-class student pages printed, it's at the back of that booklet. Understanding visual displays of information, it's a really good piece of information talking about that this thing that we're looking at. If it looks like a pie chart, then it usually is used to, and then it mentions it's to show relationships between different parts compared to a whole. And then, for example, it can be used to show like a 24-hour cycle, how your money's distributed maybe in a month or year, and how we divide something up. It also talks about a line graph, a histogram or bar graph, and a table. Make sure you go ahead and try the questions on parts A and B for this pie chart. It says, why is the following an incorrect choice to graphically display the data? And go back and look at the chart. When it says it's good for a pie chart to be used is when you're displaying parts of a whole. With that being said, these percentages are not parts of a common whole. Another thing I'd like to do is to add them up, because they should be 100% exactly. We got 8, 9, 10 over here, and then 6, 12, a little bit more. We're looking at 170%. This is not good. And so it's not representing parts of a whole, so what would be better? Part B, probably a bar graph would be a better way to display this information. One more list of information to have in your brain, rolling around in your brain, or to have memorized, are ways in which visual displays can be distorted. So some of the ways include skewing the graphs to slant the data, making inappropriate comparisons, poor use of pie charts, presenting inappropriate correlations and causation. Understanding these approaches will help you ask critical questions about visual displays. So moving on to question 3A. 3A says, select which of the 4 approaches best describes the problems with the following graphs. So it says, so what about the graph in question 1? Here's the graph in question 1. And so if you look at your choices, whether A, B, C, or D, I believe B is going to be the best choice, that it's making inappropriate comparisons. We don't have good information about what's going on, and it feels like they're just throwing something out there to say that it exists. We don't even know what it is. 3B is then asking us to look at graph 2 on question 2, and that's this one, and to answer again, what do we think is misleading? And it says, select which of the 4 approaches best describes the problems with the following graphs. So A was skewing, B was making inappropriate comparisons, and then C, well, C is using a poor use of pie charts. I think we have a winner. That's going to be a poor use of pie charts. Again, make sure that you have already hit pause and you have already worked on parts C and D before watching the video. If not, go ahead and hit pause and then come back and let's walk through them together. Looking at part C, what's going on with this? And our choices of A, B, C, or D. Well, before I look at those, let me even see what's going on. Who benefits from the components of the tax deal? You have people as compared to cost. People compared to cost with Obama's priorities. People as compared to cost with the GOP's priorities. And our possible ways that visual displays can be presented in misleading or distorted ways include A, skewing the graphs, B, making inappropriate comparisons, C, poor use of pie charts, and D, presenting inappropriate correlations and causations. We better go with B on this one because they are making inappropriate comparisons. So B on part C. Now looking at part D. On part D, it says we've got a following graph. It's the gun deaths in Florida, the number of murders committed using firearms, the 1990s, the 2000s, the 2010s, and then wow, this starts at 1,000 and then goes to 0 when normally we start at 0 and then go up this way. So it appears our whole graph is upside down. Interesting. And so parts A, B, and C, and D, wow, let's slant on that one. Part A is skewing graphs to slant the data. Part B, making inappropriate comparisons. Part C, poor use of pie charts. And Part D, presenting inappropriate correlations and causations. And I did not write this thing slanted on purpose, but it is pretty funny. But the best answer on this one is where you're skewing or slanting the data. This is very misleading. We normally don't see it that direction, and people are probably going to gloss over that. And so this is a misleading graph. So in question 4, if you took the Foundations of Mathematical Reasoning course, then you have seen these graphs before. But we are going to compare the following two graphs to determine which one is misleading and justify your response. So as we look at graph 1, it's the average household income. Graph 2 is the average household income, 2009 versus the year, okay? We got a year going on, 99 to 2009, 99 to 2009. It looks like it's going by 1 year increments. So everything looks pretty up and up right now. And then we get to average household income, Again, everything appears to be identical, but those graphs sure don't look identical. And then we get to the actual vertical axis. So this one's going $0, 10,000, 20,000, 30,000, all the way up to 50 and 60,000. And if you look at this graph, got a little thing going on. We start at $0, but then it jumps straight to 48, 49. Oh, wait a minute. This one starts at 0 and goes up by 10,000 increments. This one starts at 0, but then jumps a $48,000 increment and then just goes up 1,000 from here on out. So which one is misleading? Graph 1. Justify your response? Well, however you want to say. They start at 0, but then jump to 48,000, and then they go up by 1,000 increments, whereas the other graph is going up by 10,000 increments. It is skewing the graph, so looking at A, B, C, or D, it is skewing the graph because the same scale is not used between 0 and 48,000, which is used on the rest of the graph. And people, that does not complete this lesson. We have one more to go. How about you hit pause and go do number 5, and so will I. Now we're ready to do the last question in this lesson, which is still asking us to do the same things. It is asking us to compare the following two graphs and determine which one is misleading, but then to definitely justify our response. So looking here, graph 1, graph 2, percent who agreed with the court, percent who agreed with the court, Democrats, Republicans, Independents, Democrats, Republicans, Independents. Looking at the vertical axis, we're going 0 to 10 to 20 to 30, so we're going up 10% on each increment. That looks good so far, and then looky here. It's not starting at 0. It is starting at 50. It is going up by 2 increments from there, but it is not starting at 0%. Here's our winner on misleading. And if you look at the graphs, these look fairly similar, but when you distort your vertical axis, It looks like a huge difference between Democrats, Republicans, and Independents. So if you're going back to look at our four choices, is it A, B, C, or D? It is going to be A that is misleading by not starting the vertical axis at 0. In other words, it is skewing or slanting the data. Now I can say that we are finished with lesson 17C. You need to go look at your syllabus and see if you have more to do or if you're done. Either way, I'll still be seeing you in some more videos.